Hello, my name's Nathan Hadaway, and this is Physics 2, Lab 1 Charge Tape. In this lab, we charged two pieces of tape, stuck one of them to a table, and took the other one and put it underneath the first piece of tape and lifted it up with the electric force. That would mean that the system would be the two pieces of tape, one being free and one being fixed, and the surroundings would be the Earth with the force of gravity pulling the fixed piece of tape down. This is the video that we got from it.
It's up to you. And then you like get Fourier transform that spectrum looks something like this. Sure. Where you have
We just use that as the
There we
guide.
go.
frequency oscillation.
Base tape, use that as
We
the
need
guide.
distance measured.
That's fine. It can be long. It's the base tape. Like we're gonna charge it.
This is part of what I'm working on.
Like 2 centimeters.
Figuring out mechanisms to like actually do this.
Yeah, I'd say about 2 centimeters. All right, that's good.
As you can see in that video, we measured the distance between the two pieces of tape once the top piece of tape had lifted or overcome the force of gravity. Next thing we did is we created a glow script. We coded the same simulation in Python, and here is some of the important parts of my code, along with the entire the URL if you want to look at the entirety of the code. And finally, we compiled our data from both the real world and the simulation to see how they compared. What we're trying to prove in this is we are trying to prove that like charged objects repel, meaning that because both pieces of tape were charged the same way, they were both positive, but that doesn't really matter. Could have been both negative and they would have still repelled. Because they were both charged the same way, they repel, which we see in the experiment by the fact that the top piece of tape um, went away from the bottom piece of tape. It got lifted up by the bottom piece of tape through the electric force. We are also trying to prove Coulomb's law that charged objects, um, the force, the electric force from charged objects um, from one charge object onto another charge object can be shown by force equals 1 over 4 pi epsilon times the charges multiplied by each other over their distance squared. So we can see here, because both of them had a positive charge, that the force would be along the the r vector, which I guess I forgot to add in here. So I guess this is magnitude of force, but it it goes along the r vector from the um, source to the observation point or whatever it's called. We can see that it goes in the direction of r hat, which is shows that they repel, and then we will also be able to use the magnitude. We'll calculate for the magnitude in the glow script and see that it does in fact make sense with because we know the charges of the tape, and we do know we measured the distance between them, and we obviously know the constant k, or 1 over 4 pi epsilon. We also prove here that forces can be added to calculate an overall net force. That'll be seen in the next slide, where we see that gravity, gravity plus the electric force equal out to give a net force of 0, which is why the top piece of tape isn't moving. So here we have the simulation. You can see here on the left is again my code. You can look through that and um, see if it's all correct. I believe it is. And then on the right here is the simulation we got from it. So you can see bottom piece of tape is the purple ball, top piece of tape is the yellow ball, which has the green arrow, which is the force of gravity, and then the red arrow, which is the electric force. And then below, we can see the uh, force of gravity is the first vector you see under the simulation, and in the second one is the electric force. You can see they're very close to each other, which shows that they counteract each other and proves that the Coulomb's law here in my code is correct. A couple assumptions I made was that both pieces of tape were charged the same, and the top piece of tape was able to move freely, and there's no air resistance. Finally, we have the frequently asked questions. What if all charges were flipped, meaning all positive charges were negative charges and vice versa? Nature doesn't care what we call charges. We could call positive elephants, negative donkeys, and it'd still work the same. So it doesn't matter what we call it, still work the same. Secondly, why do we need to be quick with the tape in the experiment? That's because the longer we wait, the more the piece of tape gets discharged. Thank you for listening.